Welcome back for step 4 and 5 of graphing rational expressions. Step 4, determine if your graph has a horizontal asymptote. Hint, find the limit as x approaches infinity. We have not done any of these by hand yet, so what I'd like you to do, you may bring this version down. I like to bring the reduced one to work with. It's smaller. I'm going to go down here to step 4 and fill in limit as x approaches infinity of x plus 4 over x minus 3. If you plug in infinity, infinity plus 4, infinity minus 3, is this top heavy or bottom heavy? Does this have big boobs or a big butt? Or does it have neither? Anybody have any idea? I think it has nothing. This is nothing, because if you have infinity and you add 4 to infinity, it does nothing to it. It's still huge. If you have infinity minus 3, it's still infinity. So there is a little trick that we need to do when you have infinity on top and bottom. You divide by the highest power of x in the denominator. The highest power of x is right here. It is just an x to the first power. So divide everybody on top by an x, and everybody on the bottom by an x. So I just rewrite it and put an x under every term. You might be looking at that thinking, oh yeah, that looks easier. No, it doesn't. It is. Wait till you see what happens. Give everybody time to write that. X over x reduces to 1. X over x reduces to 1. Now I have two fractions. If I'm plugging infinity in, 4 over infinity. This fraction right here will have a big butt, so it equals 0. So cross that out and just make it a 0. If you have x on the bottom of a fraction and you're plugging in infinity, it will be 0. So then I just have a 1 plus 0 on the top, which is 1. 1 minus 0 on the bottom, which is 1. Which makes my horizontal asymptote y equals 1. Okay, last but not least is step 5. Determine your y-intercept. How do you do that? You substitute 0 for x. I'm just going to rewrite the reduced one down here to remind myself, if I'm going to plug in 0 for the x's, I'm going to get a 0 for the x, and if I plug that in, I'm sure you can see that it is negative 4/3. Why do we do that? Because it's an easy point. It's a super easy point to get. Why not get more points that are on the graph? Everybody all right on there? Now, flip it over. Now we need to put it all together. One thing, I'll go back and forth, I saw was this hole at negative 2, negative 2/5. So, negative 2 and a little bit down, I'm going to put a hole. So to the left and just a little bit down. My y-intercept was 0, negative 4/3, which is negative 1 1/3. I'll put that point there. We had a vertical asymptote. I believe it was 3. Let me check. Yes, right here it was. Vertical asymptote at 3. I'll do that in a marker here. We had a horizontal asymptote at 1. Now the last thing you need to do is put your swooshes in. So let's flip it back over. As we are approaching from the left of 3, it needs to go down because it's negative infinity. And when we are approaching from the right of 3, it needs to go up. Okay, so 3 to the left. I want to be on the bottom side here, and I know I need to because there's already points there. Just connect the dots and put in your swoosh. On the other side, it was positive infinity. So that means it needs to be on the top. Now, if you would go to your calculator and graph our function from the beginning, which you cannot do on your quiz, it would look like this. And that is the end of the 5-step process for putting it all together.